Okay, we're back for section 8.2. We're going to look at number 34. Now, section 8.2 goes into confidence intervals just like 8.1 did, but now we're going to be looking specifically at proportions. So, reporting cheating. What proportion of students are willing to report cheating by other students? A university project put this question to an SRS of 172 undergraduates at a large university. You witnessed 2 students cheating on a quiz. Do you go to the professor? Only 19 answered yes. In Part A, we're going to identify the population and parameter of interest. Part B, check conditions for constructing a confidence interval for the parameter. Part C, construct a 99% confidence interval for P and show your method. And in Part D, we're going to interpret the interval in context. So Part A, we're identifying the population and parameter of interest. Our population of interest is who we're inferring upon, and our parameter of interest is the variable of which we are going to do our inference. So the population in this case would be our undergraduates at a large university. And our parameter of interest is that variable that we're looking at, so the proportion of all undergraduates who would be willing to report cheating. And then in Part B, it says check the conditions for constructing a confidence interval. Our conditions here are just like our conditions in the last chapter. We have our randomness, we have our 10% condition, and we have our large counts condition. Since we're looking at proportions, we want a simple random sample, which was taken. Our 10% condition is we're checking to see that our sample size is less than 10% of our population size. And 172 should definitely be less than 10% of our entire undergraduates at the university. And then finally, our large counts condition is going to be done by the n times p and n times 1 minus p. Now in this chapter, since we don't know what our p is, we have to use p hat to answer that. So n times p hat and n times 1 minus p hat are both definitely greater than or equal to 10. In Part C, we need to construct a 99% confidence interval for p and show our method. And based on the conditions above, we can assume our sampling distribution is approximately normal with a mean of 0.11, which is what we got from our sample, and our standard deviation using that same formula as before since our 10% condition has been met. And that gives us a standard deviation of 0.024. Now our confidence interval should be found using p hat plus or minus our z critical value times the standard deviation of x bar. Now we just found that standard deviation, actually that should be standard deviation of p hat instead of x bar, so let me fix that real fast. Standard deviation of p hat here, since we're dealing with proportions. Our z critical value in the last section was always 2 standard deviations from the mean. So we were looking at 1 z critical value there. Now we're working with a 99% confidence interval. So I'm going to pull out my resource packet. And if you look here, it's table B, which is our t distribution. We're going to get into next section. But right now, if you look at the very bottom of that, it says on the bottom confidence level. When we were dealing with the 95% confidence level, we were right here, so our z critical value was 1.96. But now we're looking at the 99% confidence interval, so our z critical value is going to be 2.576. In other words, if we're looking at 99%, that would be however many standard deviations from the mean, and we'd be shading in between. Our area under the curve would be 2.576. So coming back here, we're going to have 0.11 plus or minus 2.576, which we just got from that table, times that standard deviation we found over here, which is 0.024. Plug all of those values in, and you would get 0.05 to 0.17 as your confidence interval. Then finally, always we're going to interpret this in context. So for this one, we are 99% confident that the interval from 0.05 to 0.17 captures a true proportion of all undergraduates at this university who would be willing to report cheating. One thing I want to point out here is make sure you always specify who would be willing to report cheating. Put it in the future tense. Because if you say who did report, as if it had already happened, we know exactly how many who did report. That's what happened in our sample. Our confidence interval is what would happen in all possible, so looking at what could possibly happen. Just like with the idea of probability, it's more in the long term, not in current, but more in the future what could happen. Thank you very much.